Hello everyone, welcome back. And today we'll be talking about your Gauss Markov theorem. So in the last video we had talked about your variance of your OLS estimators, okay, or the standard error of your OLS estimators. Today we'll be talking about Gauss Markov theorem, which basically talks about the properties of your OLS estimators, okay. So Gauss Markov theorem talks about what should be the features of your OLS estimators, how they should be behaving. Okay, so we'll see what he says or what the theorem says. Okay, so given the assumptions of CLRM, your classical linear regression model, just give me a moment. No, let me use this. Yeah. So given the assumptions of your CLRM, Gauss-Markov theorem says the least square estimators should have should have minimum variance and should be unbiased. Okay, so let's talk about these terms, what these means, minimum variance and unbiased. And also one more thing, and they should also be linear. So we already know that. So your CLRM says that your regression function should be linear in parameters. Okay, so we know that. So we'll just revisit these ideas again. Okay, so let's see what minimum variance mean. So if I am estimating my beta 2 hat, okay, and the different values, if I plot them, these are the different values of your beta 2 hat, assuming they are following a standard normal distribution. So one distribution is looking like this, and then I have another distribution that looks like this. Okay, just give me a moment. It's not. Hmm, why is it not working? Okay, yeah. So one looks like this. So okay, again, the height should be same because the only difference is coming in the variance of the distribution. So I hope you will understand. Okay, so this is also an estimate or a representation of beta 2 hat values, and this is also a representation of beta 2 hat values. So in this case, the variance of the beta 2 hat values is lower compared to the variance here. This variance, say variance 1, is less than variance 2. So the values of beta 2 hat are less spread in this distribution over here compared to this one. Oh, okay. So what this means is that the expected value is more precise, or the estimate of the expected value of beta 2 hat is more precise compared to this distribution, because the standard deviation or the variance is smaller. So my aim is to uh, go for that data where the estimators, or the value of estimators that I'm getting, has the least or the minimum variance. Okay, so I'll always go for a distribution of the values which has minimum variance. So this is a property of the estimators through which I'm estimating the real parameters. So this is one of the property. The second property, is that linear in parameters. So we know this, we have discussed this multiple times. Okay, so we will not discuss this again. So in a nutshell, it means that so no, we know this. We already know this, and we're not discussing this. So let's go to the third one, which says it is a unbiased estimate of your true parameters. So your least square estimator should be unbiased. That's what it is saying. So what this means is that the expected value of beta 2 hat, or the average value of the all the beta 2 hat that I'm getting through multiple samples, should be equal to the actual value of the beta 2 hat. So this should be a property of my estimators. Okay, so in short, what Gauss Markov theorem says is that my estimators are blue, which means best, linear, unbiased estimators. Okay, so this is a property of my estimators in the classical Ligren. Sorry, like I'm so sorry. It means this is a property that the estimators in my classical linear regression model are following. Okay, so these properties become very important, and they'll help us a lot to uh, understand a lot of concepts in the upcoming videos, because these properties become really important, and they help us in estimating the real parameter values in a more better way or more precise way. Okay, so this is all for this video. So in the next video we'll talk about a new topic. Okay, thank you.